Industrial IoT is a new and exciting trend that increases efficiency and reduces costs. This is achieved via cool technologies like smart devices or things and big data analytics. But it also involves massive data transmissions to and from many remote sites. The big challenge is doing so over many different network connections. Plus, there's the need for real-time analytics and to get actionable information from all the data collected. To solve these issues, the industry has come up with a smart approach that has become increasingly popular. It's called edge computing. So what is edge computing exactly? The most common view is a cloud environment in which storage and processing of data is performed closer to the edge of the network. In other words, it is distributed instead of being carried out at the data center. The data itself is coming from automation-enabled devices. These could be sensors, meter concentrators, or CCTV cameras, to name just a few. What connects all these devices to the operational network and to the control center is an industrial IoT gateway. And by adding cloud computing resources to the gateway, we get local storage and local processing at the edge. This approach offers some impressive benefits, which is probably why it has become very popular. First, we get higher reliability. Because the data doesn't need to travel to a central cloud, there's no risk of service interruption if the link goes down. This also enables lower delay in the network and consumes less resources compared to a centralized cloud deployment. And last, but definitely not least, we can achieve better security because the data is not traveling over public networks. Cloud computing and virtualization enable multiple applications to run on the same hardware at the same time. This means that a single industrial IoT gateway can host networking as well as non-networking functions. By non-networking functions, we mean software-based customized applications for industrial IoT management. The end result is less boxes and better security. The function that needs to be secured is virtualized within the securely connected industrial IoT gateway itself. We can also add anomaly detection, both for networking and cyber functions. The bottom line is that edge computing provides insight and agility while reducing the number of devices in remote sites. In our next installment, we'll take a closer look at some interesting use cases for edge computing. In a typical utility field area network, there are many remote sites with remote terminal units, also known as RTUs. RAD SecFlow is used to cyber-secure the data access to these devices. But the SecFlow does much more than handling secure networking. In fact, the controller or PLC software can be added to the SecFlow using edge computing. SecFlow's analog and digital inputs and outputs now make the external RTU redundant. Here we see the OpenPLC software with all its functionality within the SecFlow. The HMI user can remotely control all units in the field and adjust the operation of sensors and relays as necessary, bringing automation to the network. Not only are the number of boxes reduced, but overall cybersecurity has also been improved significantly. No one can physically access the RTU any longer, and it is fully contained within the SecFlow. In this example, we saw how the power of edge computing brought efficiency and cybersecurity to industrial IoT. With the increased awareness of the need for cybersecurity in automation environments, there are key industrial IoT applications that are meant to ensure data integrity and prevent unauthorized traffic from entering the system. Let's take a look at how edge computing can be used to secure industrial controllers or PLCs. In this case, we're adding SCADA Firewall functionality to the SecFlow. The SecFlow now monitors SCADA traffic between PLCs and logs relevant activity. If necessary, it can also actively block traffic for intrusion prevention. What we're seeing on the screen is the monitoring of DNP3 traffic. Of course, other SCADA protocols are supported. In these examples, we saw how the power of edge computing brings efficiency and cybersecurity to industrial IoT. RAD offers an intuitive development environment to add various industrial IoT applications as edge computing virtual machines. These can be distributed to thousands of units in the field. Visit rad.com to learn more about edge computing and industrial IoT.